continue with the same topic, that is vent of factor I. Vent of factor I says how much number of solid particle increase or decrease. Vent of factor I says how many number of solid particle increase or decrease, and we know that conjugating property is depends on the number of solid particles. Okay, so here vent of factor I is given by I is equal to total number of mole of solid particle during dissociation or association. Total number of solid particles during dissociation or association upon total number of mole of solid particle during dissociation or association. So total number of moles of solid particle So we continue with the same topic, that is vent of factor I. Vent of factor I says how many number of solid particle increase or decrease. So here it is given by the formula I is equal to total number of moles of solute particle after dissociation or association upon total number of moles of solute particle before dissociation or association. So vent of factor I is given by the formula total number of moles of solid particle after dissociation or association, or total number of moles of solid particle before dissociation or association. So with the help of this formula we can find out the electrolyte during dissociation as well as association. Now how is they are facing? Suppose I have taken the electrolyte. For example, this electrolyte undergo dissociation. So I have taken the 1 mole of NaCl. Yes, I have taken a 1 mole of NaCl. This 1 mole of NaCl will dissociate. Suppose here it is 100% dissociation. So this 1 mole will break into Na plus Cl minus. Yes. So So before dissociation it was 1 mole, but after dissociation it converted into the 2 mole or 2 particles. Okay. So with the help of this we can find out the I value. So total number of moles after dissociation was 2 upon total number of moles of solid particle before dissociation means 1. Okay. So it says that it is also called as observed colligative property. Yes, it is also called as observed colligative property, and this is called as calculated colligative property. So I can say that this formula I can also be written as observed colligative property upon calculated colligative property. So here I is equal to 2 upon 1. Okay. So please remember, and already I told you, during dissociation, observed colligative property is always greater than the calculated colligative property. If I say another example, MgCl2, I have taken a 1 mole of MgCl2. This 1 mole of MgCl2 break and formation of Mg plus 2 and 2 Cl minus. If we calculate the I value for this, so I is equal to total number of moles after dissociation 1 plus 2, that is 3. Total number of moles before dissociation 1. So I value will be 3 by 1. Okay. Now, so once again here same observed colligative property is greater than the calculated colligative property. Now, so this is a case for the dissociation. Now for the association. Now one more example we take. For the electrolyte, that is a weak electrolyte. Suppose I taken a NaCl. This NaCl undergo dissociation but not 100%. Not 100% means some of the NaCl molecule will remain in undissociated form. Suppose this NaCl will break into definitely Na plus and Cl minus. So what happens in case of the electrolyte which does not undergo 100% dissociation? Suppose in initial condition, initially this NaCl was 1 mole and it does not dissociate. Initial condition, I have taken a 1 mole of NaCl, it does not undergo dissociation means it forms 0 Na plus and 0 Cl minus. But after dissociation it forms the equilibrium. Okay, it forms the equilibrium. So I can say that degree of dissociation here, because degree of dissociation means it is denoted by the alpha. It says out of 1 mole, how many moles get dissociates? That is nothing but alpha. कितना अल्फा डिसोसिएट हो गया है 1 मोल में से. So suppose I can say that out of 1 mole, alpha mole get dissociates. Then what is remaining? Remaining part is 1 minus alpha. Once again, please. Suppose I having a 100 mole. I having a 100 mole of NaCl. Is 100 mole of NaCl में से 50 moles आयंस में कन्वर्ट हो गए. मतलब 50 अल्फा आयंस फॉर्म में कन्वर्ट हो गए. Then how much is remaining? Sir, 100 minus अल्फा या 100 minus 50 मतलब 50 moles बचे हैं जो डिसोसिएट्स नहीं हुए. same here. So out of 1 mole, alpha mole get dissociates, and how many is remaining? That is 1 minus alpha. So here, if we calculate I, so total number of moles of solid particle after dissociation means here, so what will be present? 1 minus alpha plus alpha, yeah, I can write in this way also, alpha plus alpha which dissociate, and also in our solution there is a presence of undissolved solid. This is undissolved solid, this is a dissolved solid. So in a container or in a solution, all three will be present after dissociation. So we can write as plus 1 minus alpha. So upon total number of moles before dissociation was 1. So I value is equal to alpha plus 1 upon 1 is the same. Alright. So I is equal to alpha plus 1 upon 1. This is for electrolyte which does not undergo complete dissociation. Okay. Now, suppose in order to prove अगर ये NaCl 100% dissociate होता, तो आंसर क्या आना चाहिए था? Answer should be 2 by 1. After dissociation, just we have to prove here. If alpha is equal to 1, alpha की value 1 कब आती है? Whenever electrolyte undergo complete dissociation, means all the molecule gets converted into the ions. At that time, alpha is equal to 1. And for weak electrolyte, alpha is less than 1. Please remember. So if we put the value 1 here, alpha value 1, answer will be, I value will be, yes, 2 by 1. So one is the same. Suppose if NaCl undergo 100% dissociation, so answer will be 2 by 1. Just in order to prove it, okay. So this is the case for the electrolyte, okay, which undergo dissociation. Either is a 100% or either is a less than 100%. Okay. Now we take the example of the weak electrolyte. Or during association. Yes, during the association. So as we know that during the association the number of solid particles decreases, and due to which colligative property decreases. So here suppose I take an acetic acid. I take 2 molecules of acetic acid. These 2 molecules of acetic acid undergo association, and during the association, what happened here? We already have seen the last video lecture. This is the acetic acid. This acetic acid undergo association through hydrogen bonding. Okay. So here there is the presence of hydrogen bonding. 2 molecule gets converted into the big molecule. Now, if we calculate the I value for this, okay, we calculate the I value for this. So total number of moles of solid particles after dissociation, yes, there is only 1 mole upon total number of moles of solid particles before dissociation is 2. So I value will be 1 by 2. Means that here calculated colligative property is greater than the observed colligative property. Calculated colligative property is greater than the observed colligative property during association. Okay. It depends on the number of solid particles after dissociation or association, and calculated colligative property is the number of solid particles before dissociation or association. Okay. So observed colligative property is equal to I into calculated colligative property. If you see, it is actually real. It is a observed colligative property with more focus. Now here we will discuss, we already discussed the 4 colligative property, because next topic is a modified form of colligative property. So first colligative property we will discuss, that is relative lowering of vapor pressure P10 upon P10 is equal to X2. What is X2? That is the mole fraction of solid. So this is your calculated colligative property. If we multiply by the I, so it becomes a observed colligative property. Same here, delta T B is equal to KB into M. Yes, KB into M. This gives a calculated colligative property. अगर इसको हम मल्टीप्लाई कर देंगे I से, so with the help of this we can find out the observed colligative property. Third, once again, delta TF KF into M into I. Same fourth colligative property, pi is equal to M RT. When it multiplied, we can calculate the observed colligative property. So with the help of this, we can find out the observed colligative property, and this formula. With this formula, we can find out the colligative property for all solids like electrolyte as well as non-electrolyte. We can use this in case of all electrolyte as well as non-electrolyte. Okay. The last topic, that is the relationship between Van factor I and alpha, that is degree of dissociation. Okay. So consider an electrolyte AXB1. Consider the electrolyte AX and B1. I have taken a 1 mole of electrolyte AXB1. This undergo dissociation and these are in equilibrium. There is a formation of AX, A plus ion, Y, B plus minus ion. Suppose if I say I have taken an NaCl. This NaCl will break into the ions Na plus and Cl minus. Now, so at initial condition, I can say I have taken up 1 mole of AXB1. So before dissociation, it has 0 ions of Xa plus and Ya minus. But at equilibrium or after dissociation, out of 1 mole, alpha mole get dissociated. Out of 1 mole, alpha mole get dissociated. So how much is remaining? 1 minus alpha. So total number of moles after dissociation will be 1 minus alpha, or I can write as x alpha and y alpha. Okay, we can also write x alpha and y alpha. So here 1 minus alpha, sorry, total number of moles after dissociation means in a solution there will be presence of undissolved as well as dissolved solid. So here 1 minus alpha plus x alpha plus y alpha. So here we will take a common here, 1 minus alpha x plus 1 minus 1. We will arrange this and we take out the common alpha. Now x plus y is equal to n, means n is a number of moles of solid particle after dissociation. So x plus y we will write here n. So here 1 minus alpha and minus 1. Okay, so sorry this here that will be plus here. Okay, so here, so this is the total number of moles after dissociation. Now as per the formula I, here our formula we discuss total number of mole after dissociation upon total number of mole before dissociation. So here I value will be I is equal to 1 minus alpha bracket n minus 1 upon n. So indirectly I can say that I value will be 1 minus alpha n minus 1. Yes, because here is only 1. Or we can also arrange this and in form of alpha, so alpha को यहीं रहने दो, alpha is here, just we have to arrange I will is equal to I minus 1 upon n minus 1. Okay, so this is the final equation. Alpha is equal to I minus 1 upon n minus 1. So this is the relationship between degree of dissociation alpha and value of